Hi guys, welcome to the next section, Reinforcement Learning. In this section, we will start with Introduction of Reinforcement Learning. We will then move to Reinforcement Learning Basics. Next, we will see Markov decision processes and Bellman equations. After that, we will look at dynamic programming and Monte Carlo methods. Finally, we will see temporal difference learning. Now, we move on to the first video of this section that deals with Introduction to Reinforcement Learning. In this video, we're going to take a look at the characteristics and few live examples of reinforcement learning. We will also see why reinforced learning is more difficult. Reinforcement learning mimics how humans learn by interacting with environment, repeating actions for which the reward that is received is higher, and avoiding risky moves for which there is a low or negative reward as an outcome of their actions. As machine learning has three major sections, let's take a high-level look at the major differences and similarities. First type is supervised learning. In supervised learning, we have a training set for which we have given right answer for every training algorithm. The training example contains all the right answers, and the job of the training algorithm is to replicate the right answers. Next type is unsupervised learning. In unsupervised learning, we have a set of unlabeled data and a learning algorithm. The job of the learning algorithm is to find the structure in the data with algorithms like k-means, PCA, and so on. Last type is reinforcement learning. In reinforcement learning, we do not have a target variable. Instead, we have reward signals, and the agent needs to plan the path on its own to reach the goal where the reward exists. Now, let's move to characteristics of reinforcement learning. The feedback of a reward signal is not instantaneous. It is delayed by many timestamps. Sequential decision-making is needed to reach a goal, so time plays an important role in reinforcement problems. The agent's action affects the subsequent data it receives. In reinforcement learning, a little bit of supervision is needed, but much less supervision compared to supervised learning. Let's move to reinforcement learning problems. First example, autonomous helicopter. The objective of autonomous helicopter is to change its roll, pitch, and yaw to control its position by controlling the joystick, pedals, and so on. Sensors send inputs 10 times a second, which provide an accurate estimate of position and orientation of the helicopter. The helicopter's job is to receive this input and to control the stick to move accordingly. Instead, RL algorithms gives different types of feedback. It will give a reward signal when the helicopter is doing well, and negative rewards when the helicopter is doing the wrong thing. Based on these signals, the helicopter controls the journey. The job of the learning algorithms is to provide the reward functions and train the path on its own. A computer playing a game of chess is another example in which at any stage of the game we won't know in advance what the optimal move would be, so it is very hard to play chess using a supervised learning algorithm. It is hard to say X is board position and Y is the optimal moves for this particular board position. Instead, whenever it wins a game, we provide a reward +1, and whenever it loses a game, we give a negative reward -1. Last example is training a cat. We give a cat reward when it does a good thing, and every time it does a bad thing, we make it clear that this is bad behavior. Over a period of time, the cat learns to do more of the good things and less of the bad. Now, we will look at the reasons why reinforcement learning is more difficult than supervised learning. First reason, it is not a one-short decision-making problem. So, in supervised learning, an algorithm predicts whether someone has cancer or not based on given attributes, whereas in reinforcement learning, you have to keep taking actions over a period of time. We call this sequential decision-making. In this video, we have introduced reinforced learning.